In this example, we are going to find out what kind of folding we have in different layers based on the Ramsay classification. And as we know, the Ramsay classification indeed is something like this. So you have three classes, class 1, 2, and 3. And based on the configuration of these isogons, we are able to categorize different folds. So for drawing the isogons, we discussed that there's an easy way to do so. What we said, you can have an axial trace and then draw the perpendicular line for it. And then for this example, we start from 60 degrees, or you can indeed start from 50 or 30. And indeed, the best guess indeed, if you look at to the fold and see what kind of angle you are expecting. If for this example, if you can draw the tangent line to the limb of the anticline at a 60 degrees, you start from 60 and then you reduce it by 10 degrees for both limbs. So here we are starting with 60. We draw the line of 60 degrees and we find the tangent point, and we redo this for the bottom side of the fold, and then you have two tangent points and then you connect them together, and that line is called isogon. You do the same thing for the other limb, and then you reduce the size of this angle, and you will end up to few isogons in both sides, and from there you should be able to categorize your fold based on the Ramsay classification. I found the easy way to do that rather than using the protractor and drawing many lines on that. What I have done, I produced a graph like this. There's a 0 line, 10 degrees, 20 degrees, 30, 40, and 50 degrees for this particular example. And indeed, I made this by computer, but if you want, you can actually draw the lines and and tilted lines using your protractor. And then what I'm gonna do, I'm going to indeed cut this paper through these lines, first through the 50 and then 40 and then 30, and then I will put this line to the side of the limbs and find out the tangent points. So I'm going to work out that one, and for the simplicity I made a larger copy of this. So I will keep this one here, and what I'm gonna do is I'm going to show you how I'm gonna cut these lines and then practice for two isogons, and from there you can keep going and complete the exercises. Okay, first of all, I'm gonna cut the line of 50 degrees. So let's do this first. Okay, great. So I have this one here. So what you can do, maybe you can keep even, maybe you can cut 0 degrees, but I'm gonna keep this because I want to, fit this line to the line that I'm gonna draw on the other page. Okay, let's start with this. First of all, what you're gonna do is you find out the maximum curvature of the point of the folds, which is, you know, the points here, 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 here. Draw the axial trace, draw the perpendicular line, and then from there we can start. I'm gonna pause the video and do this, and then come back and explain the next step. Alright, I have the axial trace. I have a perpendicular line to the axial trace, so I'll use my protractor. Okay, what I'm gonna do, I will put this line parallel with the line that is perpendicular to the axial trace, and then I'm gonna move my protractor along this line, okay, and try to find the tangent point between the top of the layers and my protractor. As you see, the 50 degrees line, it has a tangent point, okay, right here. So I'm gonna make one point here, and then what you can do, you can keep working on the layer 2 and layer 1, and then we will complete for the other side of the fold. So I'm gonna move this line along the line that I draw on my exercise page. Let's place this one here as this. Okay, so here I have my tangent point. Next, you see somewhere here, and then next, if this is short, you can actually find a trace on the bottom side. I'm gonna fit this line to that, and it seems my tangent point, it's gonna end up somewhere here. Okay, perfect. So I have this one here. So now if I connect these points, indeed I can have my isogons for 50 degrees for one side of the, you know, anticline, for the angle of 50 degrees. Okay, now I have 3 isogons for 3 different layers. I'm gonna work out on the other side of the fold. I just need to rotate this piece of paper and then place my straight line or 0 degrees line parallel with the line perpendicular to the axial trace. You move it along the trace and you find the tangent point. The same thing with this line here, line there. Okay, and somewhere here. You should do, you know, very carefully. Probably mine it's a little bit off, but if you are, you know, if you spend more time and if you are more careful, you might come up with better interpretation. So my tangent line is here. For the next one, I'm actually fitting the trace with this line. If it's difficult, what you can do, you can make a line on the other side. I think this way it's gonna be much easier to follow. Okay, this is the same trace that I see on the paper. And what I do, I will fit these 2 lines and then find the tangent point. So here I have this line, and this isogon. Okay, cool. So it looks, you see, it looks kind of, you know, symmetric, which means I did a good job on this. So what I'm gonna do, I will pause again the video and then cut the lines through 40, 30, and 20. Maybe I need 10, maybe not. We will see. But I think as soon as I get, you know, to 3 isogons in each side, I might be able to find out what would be the geometry of the fold. I'm going to pause the video and practice for the 40 degrees and 30 degrees and then come back with the results. Okay, let's do for 40 together. I just cut the 40 lines and then again I'm gonna do the same. I'm gonna keep the line, 0 line parallel with the one that I have here. So I see the tangent point is here for this top layer, and then I will move to the next layer, and that is indeed over here. The next over here. Then the next one, you know, I might. Okay, it's not short. Okay, if it's short, what you can do, you can draw a line parallel with this line and, you know, work out using that line. So I'm just drawing a line parallel with the other trace or another perpendicular line to the axial trace and use that one for okay, now this line is lined up with the second line that I drew. I'm just moving this on top of that line to get a tangent point here. So now I have it. So I am going to draw the isogons. The upside down. Okay. Okay, this is my tangent point. And the next one. Okay, so here, next one. So here, the next one, I'm going to use the second line. So we're here, and I see the trace. Okay, now it's parallel, and this is my tangent point. So we're here. Let's draw the isogons. And I think if I add one more, I can easily categorize my, you know, folds for different layers. So I'm going to do for 30 degrees and then come back with the results. Alright, I completed 3 isogons for each side of the fold. Let's look at the layer 1. So in layer 1, you see, if you do a little bit better job than I did, you might get a better estimation. As you see here, my isogons more or less are parallel with the axial trace. I think if you are more careful, probably you will see it better. So we can go back to the Ramsay classification, and as you see here, okay, where the isogons are parallel with the axial trace, indeed is a similar fold, and in similar fold it's class 2 and the isogons are parallel. So we are dealing here with class 2. Okay, this is class 2. Layer 2, as you see, the isogons are converging to the core, and these lines, okay, the angle of these isogons, it looks like 90 degrees. Okay, probably this is a little bit off, but this one and that one, just right here, and right here, and right here, here, and here, and here, you see it's 90 degrees. I think this line that I draw, it's a little bit off, but if you do more carefully, these angles has to be, okay, these angles have to be 90 degrees. So this class indeed is we have parallel fold where the isogons, okay, converging to the core, and they are perpendicular to the bottom and the top side of the layer. So here you have class 1b, okay, and for the layer 3, as you see, the isogons is diverging to the core. And if I go back to my classification, as you see, for class A, all of them are converging, so this is not the case. For class 2 are parallel, that's not the case. And in class 3, as you see, the isogons are diverging to the core of the anticline. So the layer 1 or layer 3 indeed is class 3. Okay, that's it.